morning, children. Now on the screen you are able to see the first lesson, that is reflection of a light at a curved surface. Why we are doing this? As a part of a SA1 revision. So I am revising from the first lesson some important topics and give some important questions. Questions means don't feel that teacher these questions are expected questions in an exam. The concept most important related to that questions are most important. Okay. Now let us discuss what is the first concept we studied here about the concave and a convex. So by seeing the activity 1, what you are understand that 1b figure 1b and 1c, you can see that when it is bent inwards, all the rays will converge. When you bend outwards, all the rays will diverge. The sole, the rubber which is bent inwards, it acts as a concave. This is a concave and it is said to be a convex. So when it is bent, what happens? All the fingers will come closer. When you bend outwards, automatically they will diverge. This is one concept we discussed, and little bit of geometry related to that. Midpoint of that curved surface is said to be a pole, and where the point from where a perpendicular line is drawn to the curved surface is said to be a center of curvature. The line which passes from pole to the principal axis, center of curvature, is said to be a principal axis. Pole, midpoint of the curved surface is said to be a pole. The line which passes from principal axis to the pole is said to be passes from pole to the center of curvature is said to principal axis. The point where all the normals will converge or a perpendicular line so will drawn or they converge at a point is said to be a center of curvature. Here some rules are given. What are that rules? Now you can see the figure. Figure 3, when the 2 nails are stuck on the thermocol ball or a thermocol wooden base, that is a base. When source is very close, what happens? You are getting the image like a diverging. You can see the in figure 3, first figure, source is very close, that is a candle. Source of a light is a candle here. You can see the diverging images. The pins are moving like this. But when the source is far away, we will get the parallel image. So, can you find such source where which is far away from us and continuously gives the parallel rays? Yes, like a solar sun. Sun is far away from us and is continuous rays, parallel rays. When these parallel rays strike a concave surface and reflect from there and converge at a point, and that point is said to be a focus or a focal point. The distance between pole to that focal point is said to be a focal length. What is a focal point? The parallel rays coming from the sun. When it strikes a concave surface, it reflects and converges at a point, and that converging parallel rays reflecting converging surface is said to be a focus or a focal point, and the distance between focus and the focal point is said to be a focal length. And one more topic also left to discuss, that is radius of curvature. Distance between P and C is said to be radius of curvature. Distance between P and F is said to be a focal length. And the relation between focal length and radius of curvature is given with a simple formula, that is R is equals to 2F. R is equals to 2F. So most important activity, lab activity, observing the different types of images when an object is placed at different places. Take a V stand, place a concave mirror on that, and locate the midpoint. From that a line draws. Draw the line which acts as a principal axis. The flame should be on above the principal axis. In such a way you have to arrange the candle. Now take a small paper piece which acts as a screen. Move the paper below the principal axis here and there so that you can get the image of that candle, and that will be your focal point. Okay. Now moving the object at different places, you will get the different types of images. So you have to do practically and write the result. Next, see, to write that we have some situations in the figure 8. Now you can see which type of surface it is, Amma? Concave. And where a ray is coming, R1 is ray is coming from the source and striking the mirror at one place. Where from that it reflects and passing through the focus. So this is the first situation. Any ray coming from the source which is parallel to principal axis strikes a mirror and reflects, passes through focus. That is the first situation. Second situation, any ray passing through focus on reflection, it will be parallel to the principal axis. Parallel to the principal axis. Third situation, any ray passing through center of curvature on reflection, it passes through same center of curvature. Now, see, this is the thing. To get an image, always you need to consider two rays. Where is the object now? Behind C. And how many rays are considered? 2 rays. Now you check R1, how it is parallel to principal axis. Definitely it passes through focus. And R2 is passing through focus. Definitely on reflection will be parallel. And both are converging at a point A. So converging point of the 2 rays, reflected rays, will be the position of the image. When object is behind C, where you will get the image? Between F and C. Which type of image? Small image, diminished image. Next, when object is between F and P and F, where you will get the image? Infinity, we don't know. Next. Third situation, when object is on C, where you will get the image? On C only. How will be the size of the image? Will be the same. And what is a virtual image? If it is caught on a, if it is cannot caught on a screen, but it can, we cannot get this on the screen like a real image. Means virtual image cannot be caught on a screen, but it can be seen directly in the mirror. Such image is said to be virtual image. And if it is caught on a screen, then it is said to be a real image. Real image. And next, ray diagrams also we discussed. These are the ray diagrams to draw for the convex. Same only, but it appears to be ray is parallel to convex. On reflection, passes through focus. Any ray passing through focus on reflection, it will be parallel to the principal axis. Any ray passing through center of curvature, on reflection it passing through center of curvature. And derivation is not important, formula is important. Long back only I said that is 1 by F is equals to 1 by U, 1 plus 1 by V. This is known as, what we say, which formula it is? Mirror formula. Sign conventions. All distance should be measured from the pole. And the distance which are measured in the direction of incident light to be taken positive, and which are measured in the direction opposite to the incident is taken as a negative. Height of the object is taken as a positive if it is above the axis, and the height of the object is taken as negative if it is below the axis. So these are the some sign convention. Last topic of the lesson is magnification. Magnification, M is equals to HI by HO, that equals to minus V by minus U. Ratio of height of the object to image to the height of the object, or image distance by object distance. Okay, this is known as a magnification. And based on that we have one formula, application of a concave mirror solar cooker, making solar cooker. So with this we completed our lesson. What are the important points to be discussed? Concept. First is focal point, that activity 1 is most important. How you will find the focal point? Place a concave mirror towards the sun such that the parallel lines will strike the mirror, and reflects all the reflected rays are converge at a point is said to be a focal point or a focus. The distance between focus to focal point is principal axis to focal point is said to be a focal length, and relation between focal length to radius of curvature is, that is, r is equals to 2f. Magnification is hi by ho, that equals to minus v by minus u. Concave mirror surface always light rays converge, and convex always light rays diverge. Three situations: any ray parallel to principal axis, when it strikes a concave mirror convex, it passes through focus, and any ray passing through focus on reflection, it will be parallel to principal axis. Any ray passing through center of curvature on reflection, it passes through same center of curvature. So this all we have discussed, and this is the most important table. You underline it. Where is object between mirror and f? Where you will get the image? Behind the mirror. Which type of image? Enlarged, inverted or erect, real or virtual. On focal point at infinity. And position of the candle between f and c, behind c, enlarged, inverted, real. On c, same size, inverted, real. Behind c, between f and c, image inverted, real. At infinity, at focus. These are the some important, you have the important for long answer on this table. Underline and write one time in your classwork. Turn the classwork from the back of the classwork, you write one time. Okay. Now underline the second question. State the difference between convex and concave mirrors. Next, fifth one, sixth one, second, fifth, sixth. Next, application of a concept. Magnification produced by a mirror is +1. What does it mean? Next, third one. If spherical mirrors were not known to human beings, guess the consequences. Next. Fifth one. Show the formation of image with a suitable diagram when object is placed on the principal axis. Okay. Fifth one. And next, activity. One lab activity we discussed on different types of images, that also important. So with this we have finished the first lesson, important concept and important question answers. Focal point, pole, center of curvature, radius of curvature, focal length, and principal axis, concave mirror, convex mirror, finding the focal point and different types of images, sign conventions, mirror formula, magnification. This topic should be read perfectly, and whatever the questions I am saying, write in a classwork one time and learn the questions. Okay ma? Now thank you children.